Electronegativity differences. Electronegativity differences is defined as the absolute difference between the electronegativity of the two atoms. Let's look at an example. CH. So in order to find the electronegativity value, remember we have to look at table S. So on table S, the electronegativity value of carbon is 2.6, while the electronegativity of hydrogen is 2.2. So we're going to write that down. So the electronegativity value of carbon 2.6, of hydrogen is 2.2. So therefore the electronegativity difference of CH is 0.4. So again, to reiterate, you take the electronegativity value of one element and you subtract it from the electronegativity value of the second element to get the electronegativity difference. So now, depending upon the range, we can identify what type of bonding we have. So for ionic bonding, we generally have a range that is greater than 2.0. So the electronegativity difference range is greater than 2.0, while covalent is generally less than 1.7. So between covalent, we have two types of covalent bond. We have a non-polar covalent bond and a polar covalent bond. Now, a non-polar covalent bond is generally 0.5 or less. And this means that there's about equal sharing of the electrons. So the electrons are being shared equally between the two elements. Remember that in covalent bond, we have actual sharing of electrons, while in ionic bonds, we have the transference of electrons. In a polar covalent bond, we generally are looking at a range that's greater than 0.5 and less than the 1.7. So this means there's unequal sharing of electrons. Now the ionic is greater than 2.0, but the covalent is less than 1.7. So what do we call the bond between 1.7 and 2.0? Well, here's something to know. If one of the atoms is classified as a metal, then it is an ionic bond. But if both atoms are non-metal, then it's a covalent bond. So again, if the electronegativity difference fall within the 1.7 and 2.0 range, and if we have one of the element a metal, that's ionic, and if we have both of them being non-metal, then it's a covalent bond. So let's take a look at the example for NaCl. Now, Na sodium has an electronegativity of 0.9, and it has and chlorine has electronegativity of 3.2. So let's write that down and determine what the electronegativity differences is. So chlorine is 3.2, sodium is 0.9. That gives us the electronegativity difference of 2.3. So remember we mentioned that if the range is greater than 2.0, then that will make it an ionic bond. Okay. Now this makes sense because remember that sodium is a metal, while chlorine is a non-metal, and metal plus a non-metal normally yield a ionic compound, and so that makes sense that this would then have an ionic bond. Let's take a look at another example. In this case, we have carbon and oxygen. Now carbon has a 2.6 electronegativity, and oxygen has a 3.4 electronegativity. So let's go ahead and calculate the electronegativity for this. Now remember that the electronegativity is only calculated between two elements. So in this case, we have carbon and we have oxygen, and the relationship is between carbon and oxygen. So let's go ahead and calculate that. So in this example, oxygen is 3.4, carbon is 2.6, and therefore the electronegativity difference is 0.8, which because it's 0.8, it is less than 1.7, which make it covalent, and because it's greater than 0.5, it make it polar. So this is a polar covalent bond. Okay, so this is a polar covalent bond.